All right, once again, organic chemistry, percentage, we all know plus minus 40%. And if you think about it, all right, organic chem, can it come out in practical? Very unlikely. All right, planning question, maybe functional group. QA, maybe organic QA, but it won't be like a lot of marks, which also means where will the 40% come in? You come into your written paper. Oh, agree? So maybe your paper 1 MCQ, paper 2, and paper 3. All right, so it's very, very heavy on them. In case you're still not aware, it should be that way. All right. We should have more control, theory paper. Right? Practical, we just a wild horse. We don't know what horse will come out. Oh, so here we go. H2 organic chemistry. What do we need to know? One at a time. All right. So here we go. First of all, I think the topic called introductory topic is very, very important. I always emphasize on this topic. All right, the intro topic. In case you haven't run through one round of it, please go and take a look. Introductory topic. Introductory, right? Topic. So over here we learn a lot of things, really, really a lot, right? And I think this is very important. I'll just list them, a few of them, all right? So we learn a couple of things. We learn how to name nomenclature. So of course, you cannot name, you cannot draw, then can't do much in terms of a lot of physical and chemical properties, right? So nomenclature. We also learn about the different types of formula. So this is the one that I worried for some of you, because not very careful. If they want structural formula, you have to give structure. They want skeletal, you have to give skeletal. What else we learn over here? We learn about the different types of formula, the nomenclature. We learn about the different types of reaction in general. Right, types of reaction. So in general, we'll say, okay, how do you know it's electrophilic? How do you know it's nucleophilic? We haven't even talked about nucleophilic sub or nucleophilic add. Right, then you have addition, subtraction, addition and substitution. Right, so the types of reaction. What else we have over here? Do we know how to do your basic reaction mechanism? Right, do you know the half arrow and the full arrow and the half full arrow? And what else we have over here? I think very important is, of course, the big one, which I'll move it out here. The isomerism. Okay, I think it's so important. I'm going to move it out. Isomerism itself. All right. So isomerism can't really memorize. You got to play with them. So isomerism in by large got how many types? Isomerism, I believe there are 2 main types. If you still remember, it's called structural. Can someone tell me structural isomerism itself has how many more types? So we split it up further. Structural isomerism, and there are 3 types. Very good. All right. So you got to know all these things.
There's functional group isomerism, as far as I remember.
Okay, I'll just list it not in any order. Doesn't matter.
Then there's constitutional isomerism.
Sorry, second one is what?
Constitutional isomerism.
Constitutional is structural. Be careful. So
they're the same thing.
Yeah, they are the same thing. So be careful. That's why I want to go through one round with your constitutional. I need to get you all to back into the basic, because question you have more than enough, and you'll be doing. I'm very sure. So I'm not so worried. Okay, towards the end of it, we'll be doing a lot more. All right, if you have time. So structural means constitutional isomerism. It's the same word, same word. Right. So from there you branch out to become functional group isomerism.
Chain isomerism.
You have chain isomerism, the straight chain versus the branch chain. And there's one more. Do you still remember? Positional isomers. All right. So position of your functional group of your substituent. Yes. And especially important positional isomerism in arenes. Remember? You got 6 sides. Keep coming out, right? This is our question. Positional isomerism. They're not chain group, sorry. Chain isomerism. Functional group, chain, and positional isomerism. Good. Now, then we go to the next one. All right. Which is, of course, very important to us, the stereoisomerism. Stereoisomerism itself has how many types? There are 2 types, yes? We have your number 1, your enantiomerism, also known as optical isomerism, correct? We talked about optical activity. Or optical isomerism. And of course, there's also your cis-trans isomerism, also known as geometric isomerism. Right? So basically, isomerism, you got to play with them. Because the question, if you come out, they ask you to what? To draw out all the isomers. You have to consider all of them. Both your structural, also known as constitutional, as well as your stereoisomers. Right? So got to be able to get this out. So this is your isomerism. What else we need to know? We need to know about something called reaction mechanism. May I know how many standard reaction mechanism is in your syllabus? Someone give me the magical number. When I ask for a number means you're supposed to prepare a number.
6.
You should know how many are there. Sorry?
6.
There are 6. Anyone has a different number? Because my number is not 6. Alright, so you prepare in the head, there's something novel, you learn it, good for you, but I need to know bare minimum 5. Total, there's 5. Alright, so here we go. Which are the 5? List it all out. Alright, in terms of topic, from first to last topic. The total, there are 13 topics.
There's your free radical substitution.
Very good. Give me a moment first. So I'm going to list them out. Alkanes, we talk about free radical substitution. All right, all these then now you know. Yeah, of course. But you cannot say, I now then recap. No, in exam, you got to be very, very clear. All right, alkenes, electrophilic, addition. Of course, then you have the third one, which is your arenes, down the list, right? And we learn it in this way, right? In this sequence, electrophilic substitution. And then you have the fourth one, reaction mechanism. Okay, I would like to box it the other way around. Okay, never mind. I'll just do it this way. All right. I'm going to do this. I forgot to add one word in. I think it's important. This is what I call the standard 5. Okay. Here we go. I'll just list it this way. This is the 5 times standard reaction mechanism you need to know. Later on, there will also be what? There will also be the novel reaction mechanism, which is new. All right. I go to that later. So arenes, after that, what is the other topic? Come on.
You guys also have nucleophilic substitution. I
Thank you.
think that
All right,
one's
your
like haloalkanes.
alkane, also known as alkyl halide. Again, two words, both words I want you to know. Alkyl halides, the RX. All right, which everyone knows this is your nucleophilic substitution. Must be very smooth. And then
Wait,
number
but there's
5,
also elimination for alkyl halides.
yeah, elimination. The thing is it's not part of the standard. So I'll shift it
that
to
one-
next. I'll talk about that in a while. And Nova will
okay.
further split. All right. So we need to be very clear. All right.
Then
So
there's
alkyl
nucleophilic
halides,
addition from for I think was cyanohydrins.
cyanohydrin, everything like not just cyanohydrin, carbonyls, addition. Okay, so these are standard 5, everyone. Is 2 to 3 marks usually. Standard reaction mechanism. Please prepare yourself. Don't miss this, miss that. Go in, just be comfortably, close both eyes, maybe 1.5 eyes, and then just finish up nicely. It must be fast. You cannot go there and start to recap. Arrow, single, reversible. All right, what do I need to add? Oh, okay, Ken, then you want, we can put it in. Indeed, there's a SN1 mechanism and there's a SN2. SN1, SN2. All right, then let's talk about the novel one, right? The novel, I will further actually split into 2 types. Why I will say that, all right? In fact, I won't split into 2 types first. I will say novel, what do we see over here? So this is you prepare, right? 5 standard, nothing much to say. You prepare, go in, you're supposed to get full marks. But the normal one, what happened? You need to what? They will always give you instruction. So you go what? You go to, you have to follow the bullet points. They will always give you, usually in bullet points. Follow the bullets. They'll tell you what is happening in step 1, the step 2, the step 3, which one is a rate determining step, which is slow step. It's always that, like that. Which brings us to what? Can you do it on your own without memorizing? Which brings us to here. There are some basic things, which is the curly arrow and, I mean not curly, the full arrow, the complete arrow, and the partial arrow. All right? Which is counting of electrons and whatnot. Now, this novel, we actually wanted to split into 2 more. Why? Because some of them you can, if you want, you can kind of prepare in advance. I won't, but it's something that we've seen before in chemical reaction. In our syllabus, just that we are not taught. We don't need to write reaction mechanism. One of them, Lucas has mentioned, example like what? These are the common reaction. The common one, then you have obviously the uncommon one. Who are the common one? The common one will be things like what? Like elimination. So as you do your revision packages, you likely have come across some question already asked. So give you 3 marks, all right? They tell you what is elimination. Step 1, step 2, step 3 was it? Then you follow, all right? So just to let you know, all right? So you hear it. Then of course, remember acyl chloride, acyl halide, right? Over there towards the end, carboxylic acids and your carboxylic acid, right? We can do halogenation to it, make sense? To form acyl substitution. What is the reaction? That one is also nucleophilic substitution, but it's a bit special, correct? So it's nucleophilic acyl substitution. Remember all these things? All right, nucleophilic acyl substitution. Etc. Etc. Right? I'll just put it here. But I still under novel because they will teach you what to do because it's not the standard 5. So technically, just follow the bullet point, it will be fine. Nothing much. Everyone okay? Also, these are all the standard stuff, right? The reaction mechanism. Let me rewrite here because I want the space. All right, we start slow. Later, then we work at question already, okay? So 5 times standard. Okay, I want to talk about all the basic things. And then they love to ask us also what? In different homologous series, I don't have to list them down, but there are some homologous series, they'll ask us, all right, some standard question regards to these 3, which is known as your acidity, which is our first thing we discussed today. All right, okay? So we will talk about acidity. What else do you talk about? They ask you to compare about 2 molecules, right? Acidity, basicity, as well as what? Who knows?
Reactivity.
Which you can prepare in a head. And it's very common. If you've done TYS, it keep coming out paper 3. Paper 3 is the one you can prepare. Paper 2,
volatility.
Start with H. The rate of
rate of hydrolysis.
Hydrolysis. These are the 3 that you'll keep asking.
Also, isn't acidity and basicity the same thing?
Acidity, basicity, different. Acidity talk about acid group, basicity talk about basic group, organic compound. All right.
Yeah, but the principle is still the same in that.
Principle the same. Yes and no. Later we take a look. The keywords you write is different from my understanding. Yes. All right. So acidity. Let's talk about the topic first. So acidity. What are the few homologous series they ask you to compare? Can you recall? Yeah, they always talk about the few, right? They'll ask you to talk about what? Alcohols lah versus who? Alcohols, the phenols. All right, and of course, we already know what will come out. Usually acidity. So they're all acids, for example. Okay. Of course, we ask for pH, then acidity basically combined together. Make sense? All right, of course, I can say about the pH. I can combine together and ask you to talk about the pH. List them in decreasing pH. Correct? Make sense? All right, so all the basic stuff, then push it to the nearer to the 14 mark, or won't be 14 because they're all weak. Okay, so towards the above 7, right? Acidic will be lower than 7. Make sense? So what else over here? You have, of course, your carboxylic acids, your alcohols, your phenols, your carboxylic acids. Make sense? And they likely also add in acyl chloride. Acyl chloride does not have acidic group, if you still remember, but the problem is it reacts vigorously with water, remember? Can someone tell me it reacts with water gives you what? Acyl chloride, remember? Acid chloride, react with water. Makes sense? Correct. I remember. Long time never do organic already. And Plaza, don't challenge it. I'm not as young as you. Memory not good. But I remember it touches water. I also long time never touch organic already. Very long. Okay? The last time I touched, the last time I taught you all. How many months ago was it? Alright. Your acyl chloride, your acid chloride. Alright. They dissolve in water, alright, to form hydrochloric acid. Remember? That's why I got the pH mark. So the pH. Okay, let's talk about basicity. In your organic functional group, ladies and gentlemen, who are basic? Who are basic?
You most likely your amides.
Your amines, which are weak basic.
Oh yeah, okay.
And they will always, of course, your amines, then you have the benzene amine. By right, it's together, but never mind, I write it down, right? So you got alcohols, got phenol. So then, of course, they love to ask you to test, talk about this. It is not basic, all right? But they'll ask you to compare them, which is your A.
Amides.
Amides are neutral.
Oh, okay. Non-amphoteric.
Okay, they are neutral. So these are the things that will come out. So we prepare. All 3 papers will come out, all right? And this, you should be yawning. Make sure you're yawning. If you're not yawning, yes, I need you to be bored with it. All right, difficult question, can't do another one. The structure evaluation 10 marks is so difficult. There are a lot of people can't do also, but the basic marks, I need to get full marks. Hydrolysis, what would they ask about? Which are the hydrolysis? What do we hydrolyze? We hydrolyze they always ask you to compare the what? The alkyl halides, the RX, then the aryl halides, the benzene ring X, remember? Aryl halides. And the last one, they ask you to play, which is what? Hydrolysis. Remember what is hydrolysis? This organic compound put the water, then water will cause the breakage of a bond. Remember that part? Hydrolysis. This is your acyl halide again, which is your acid halides. Everyone okay? The first two belongs to the halogen derivatives topic. The last one is carboxylic acids and derivatives. Okay, let me carry on from here. Then, of course, every one of them, ladies and gentlemen, because of its functional groups, except alkane, all right? Each of them, because of its functional groups, there are things that we'll be looking at, of course, which is what? And usually it's due to their functional groups. Besides chemical properties, there's something else we are also looking at, right? So, the functional groups will first lead us to the difference that you ask in terms of what? In terms of their melting point and boiling point, i.e. the physical properties, remember? Melting point, boiling point. Then we'll also talk about things like probably solubility, density, and whatnot.
Yeah.
Okay, melting point, boiling point, solubility, all right, things like that. As well as density, probably, all right. And this is the one whereby it's heavily linked to what? Usually, most of the time, is due to your what? We are in chemical bonding based on intermolecular forces of attraction. So where are we? We are bonding IMF. And the functional groups, of course, will then give us or affect the chemical properties. Chemical properties means chemical reaction. And from there are 3 standard type of questions they will ask us. In fact, there are 4 of them. 1, 2, 3 should be 3. All right. So let's list them out. Number 1, not in any order, right? But I can write this down. First of all, they'll ask you to talk about reaction schemes. Correct? How you from a reactant, and then how you get your final product over there. So this is where you have to put in all the reagent, the conditions, right? The R and C. So you have your reaction schemes. Kind of question. You have obviously also have your distinguishing test because of the functional group differences. And each of them, we played them slightly differently, if you still remember. And third, obviously your favorite, usually more than 5 mark, your structure elucidations. In general, I think kind of plus minus like that. Agree with me? Anything else that I kind of missed out that's very, very important? That's really, very important. Alright. So I want to have that feel. Like inorganic is about equation, about state symbols, about the arrow single reversal. Make sense? Inorganic. It's about the equation. Correct or not? It's keep writing equation. Okay, I think there is one more. I call it the special effect. So when the question you play, then isomerism also play in already. Alright? No, chirality is under optical isomerism.
Oh, sorry.
Okay. So these are 3 things when it's kept very, very weird. We need to be very, very careful. We know them, we've seen that before. Alright, ladies and gentlemen. First one, your inductive effect. Correct? So we compare the functional group, finish already. Then something happened to the molecule. They have all the same functional group, but because you have more alkyl group, alright, or another substituent group, then we talk about the inductive effects. All right, besides inductive effect, there's two more. It's usually the question whereby you get stuck already. I revised everything, I'm quite good already. Right? But then why suddenly they tell me the reaction don't occur? Something like that. So we think of, inductive effects, electron withdrawing, donating power, right? Or groups. And what else we always think about or play about? Something called ring strain. Third one, you'll find this more familiar, start with S. Anyone? You should confirm I've seen it a few times already. Alright? Bernice's mouth is moving. Should be that one, right? Bernice, is it this one? I chance upon you in the middle of my screen. This one, right? Steric hindrance. So whenever I find very weird already, you're like, this one can react now. Why you suddenly tell me cannot react? Or compare one molecule to another. This molecule should be about similar reactivity. Why suddenly more or less reactivity? Usually it's under these special effects. So got to think from there. Okay? So by and large, alright, this is what we do. Organic chemistry. Okay, let's cover some very basic one. I'll just run through them, 12 pages of them, alright? So then we go for a break. After a while, we come back and look at some question.